My name's Tony. I'm in the electrical engineering major, and this is the project that I'm doing. It's a Segway. It's a balancing robot that balances on its own using a pi control algorithm. Basically, it'll stand up by itself.
Okay, great.
Still a little rocky.
Yeah, oh, that's good though. So the circuitry on the bottom here is just the main controller underneath?
This is just one controller that I interface with to read the data, but the main controller on top is what is the control algorithm. So basically what it does is, using a pi controller, it has a proportional gain, which basically just adds or subtracts to the current error.
Right.
And then it has the integral gain, which basically just continuously sums and then is multiplied in the end. So once the set point changes and it starts tilting one way or the other, the gain, it basically controls how, like, the magnitude of the error and to what to correct it with, basically.
I see. Wow. So it's really just balancing on. It's basically like an inverted pendulum problem. Yeah. I've heard before.
Yes.
Now the sensors. What kind of sensors do you have up here?
Uses a accelerometer and a gyroscope.
Accelerometer and gyroscope. Okay. And what do each do? So the gyroscope does what?
So the gyroscope is to measure the rate of change,
okay,
like the rate of tilt,
yeah,
where
okay,
the accelerometer is actually measuring like the long-term, like the tilt angle itself.
I see.
And then they are integrated into, they're actually combined into a low-pass filter, and they basically complement each other.
I see.
To
right,
basically give you a accurate tilt.
So if this was full scale, you could actually stand on this like a Segway, and by leaning this device forward or backwards, it would actually,
yeah,
compensate by trying to balance itself. And that's basically
right,
how the Segway moves and propulses itself, right, as well.
And like normally, like the Segway doesn't actually balance itself. It uses the rider to balance it, where
right,
this is actually balancing itself.
Oh, okay.
So I don't, larger scale, it might be, I think it would work very well.
Yeah, great. So the program over here you have on the screen, what is that?
This is just basically using the RS-232 and sending wireless data using an XP sensor.
Okay,
but this right here doesn't.
No, you're just indirectly gathering data from this to kind of work with the
right,
what you have
right.
going on.
So that way I can convert it into digital data.
Now you're about in your second year of Penn
Yes.
College now.
Yeah, this is
okay, of the 4-year.
Yeah. Yep.
Yeah, and you think this will turn into a senior project for you?
Yeah, I would like it to. I would like to build on it and expand and incorporate basically everything that I learn into my senior project.
Yeah. Okay.
Make it a larger scale and maybe turning it into something else using like the same control technique though.
Yeah. Okay. Have you thought about putting maybe video on it or making it more into a robot that can be remotely controlled or autonomous? Or
yeah, I would like to put video on it and maybe make it remotely controlled. Wirelessly would be nice.
Yeah.
And then maybe put GPS on it so it could track its location.
Right.
And then send back all the data, maybe from different sensors and video data, stuff like that.
Okay. All right. Terrific. All right. Well, thanks, Tony.
Thank you.